3.2a, I'm just going to show you the second method on how to solve a system of equations. This method is called substitution. And what you're going to do is, I'll just write down the steps and then we'll go walk through them in our first example. You're going to solve one equation for one of its variables. Once you've done that, you substitute the expression from the equation into the other equation and solve for the variable. In step 3, you're going to substitute the answer that you got in step 2 into the revised equation from step 1 and solve. Then the last thing you do is check the answer in both original equations. Let's walk through a few. So step 1 said pick an equation and solve for one of its variables, which this is already done. If you look at the first equation, it's already solved for y. What I know is y equals 2x. So then step 2 says take that answer or the expression from that equation and you're going to substitute it into the second equation. So here's what I know. I know that the value of y is the same as saying 2x. So I'm going to go to the other equation I didn't use, and where I see y, I'm going to take the y out and I put in its place 2x. I substitute it. So I would have 4x minus, it used to be y, but y is 2x, so I put that in its place, and I say equals 6. And then you solve for the variable, so 4x minus 2x is 2x equals 6, and then divide by 2, so x will equal 3. So then step 3 said, okay, take that answer that you got from, we just did this second equation and solved, take that and go put it back into this first one here to see what y is. So if you do that, you're going to get that y equals 2 times the 3, or 6. So we just found the ordered pair of 3, 6 as the answer. Because remember, the answer is, if I graph them, where they would cross. So the answer is an ordered pair format. If we put 3 in for x and 6 in for y, you actually will get the correct answer for this system. Let's look at another example. This one does not have step 1 done for us, which says take one of the equations, find a variable, and solve for it. Now, the trick is to look for the variables that are just by themselves. So what I suggest is either getting this y by itself or this y by itself, because they're the easiest ones to clear out. Let's just focus on getting this second y here by itself. To get it by itself, I have to move 3x, so I minus 3x from that side. Then the equation would be y equals negative 2 minus 3x. So that came from the second equation. Therefore, I have to now use the first equation because I didn't use it yet. And what I know is this. I know that y equals this entire piece. So I go up to the equation I did not use and I find that y value, which is right here. I take that y out and I replace it with what y stands for, because y stands for negative 2 minus 3x. So if you do that, the first equation can be rewritten as negative 2x plus, that y isn't there anymore, I'm going to put this negative 2 minus 3x and say equals 8. I'm going to simplify. So negative 2x minus 2 minus 3x equals 8. I'm going to combine these two like terms. They're on the same side, so just crunch them together into a negative 5x. Don't add the opposite. Minus 2 equals 8. Now I'm going to add 2 to both sides. negative 5x equals 10. Divide by negative 5. X equals negative 2. Now, I got that x is equal to negative 2. So what I can do now, I can actually go put that x back into either value. I can put it to this x or I can put it to this x. It really doesn't matter. I'm going to take this x here and I'm going to go put it back just into this top one right there. So I'm going to write negative 2 times my negative 2 that I found plus y equals 8. This is 4 plus y equals 8. If I subtract 4 from both sides, y would equal 4. Therefore, my answer to this system is if I graph them, they're going to cross at the ordered pair, negative 2, 4. I can check it and put the negative 2 in for x and the 4 in for y and see if it works, and it will. Okay, let's look at this one. Now, you actually can solve for any one of these variables to get it by itself. I could solve and try to get this x by itself right here, or that y, or this x, or that y. You just want to find the one that's the easiest. So look at it and look for the variable that's already just a normal variable with nothing else. That's this guy right here. That's the one you want to solve and get by itself. It'll be the less amount of work. So let's take this second equation and solve for x. So I'm going to move the 2y by subtracting 2y. So x equals 3 minus 2y. Okay, so x is this entire piece, and I just used the second equation to get that. So I have to use the first equation. So I have to go to the first equation, and I'm looking for the x in that equation. There it is. That value gets replaced with the 3 minus 2y. So I would rewrite 5, take that x out and put 3 minus 2y in its place. Then do minus 3y equals 2, and you solve. Distribute the 5. So 5 and 3 is 15. 5 and negative 2 is negative 10. Minus 3 equals 2. So 15 minus 13y equals 2. Next, subtract 15. So it's negative 13y equals negative 13. Divide by negative 13. Y is going to equal the number 1. Now if y is 1, I can go and plug it in either to this y here or to this one. It really doesn't matter. I'm going to pick the second equation. So I'm going to take this y value, plug it into there, and see what I get. So I will leave you with x plus 2 times a 1 for y equals 3. To solve this, I'm going to subtract 2 from both sides. Therefore, in this case, x equals 1. If I graph these, they're going to cross at the ordered pair 1, 1. Another example. Now again, just stop and look. Which variable do you want to get by itself? This x, that y, this x, or that y? The easiest one is going to be to isolate this single y because it's already cleared out. All you have to do to isolate that y is to move the negative 4x over, so add 4x to both sides. If you do that, you're going to get y equals 4x. Okay, so I know that y equals this entire piece, and I used the first equation. So I must go to the second equation and find the y, which is right here. I take out that y and put this new value of 4x in its place. So we have 2x minus 3 times 4x equals negative 10. To solve, 2x minus 12x equals negative 10. 2x minus 12x is negative 10x. Divide by negative 10, x will be 1. Now to find the y this time, I'm going to choose to take the x of 1 and put it into that x value. So that's going to leave me with negative 4 and then a 1 plus y equals 0. That's just negative 4 plus y equals 0. Get y by itself, add 4 to both sides. Therefore, y equals 4. And the ordered pair answer is 1, 4, which is letter B. Now this last one doesn't really have a shortcut. You just want to think strategically what's easier to get by itself. This x, that y, this x, or that y. I personally am going to go to the second equation and try to get this y by itself. That's just where my eyes go. So to do that, I'm going to first add the 3x to both sides. Leaves me with a 3y equals 27 plus 3x. Okay. Now we'll get rid of the little 3, so that gets divided there, there, and there, which will leave me with y equals 9 plus x. So y is this entire piece, and I used the second equation. So I must go to the first equation and find y. That goes in its place. Let's rewrite it. So it'll be 3x plus 8 times 9 plus x equals negative 5. So I'm going to distribute the 8 and get a 27. And then the 8 to the x would be 8x. I'm going to combine the 3x and 8x, which is 11x. I'm then going to subtract 72 from both sides and get 11x equals negative 77. Divide by 11. X here is going to be equal to negative 7. Now if x is negative 7, I'm going to take that value. I'm going to choose just to put that back into this x value and solve. So over here in this corner, I'm going to do 3 times negative 7 plus 8y equals negative 5. It's negative 21. I'm going to add 21 to both sides. So when I add 21 to both sides, what's going to happen? It's going to become 8y equals 16. Divide by 8, y is 2. So the ordered pair answer is negative 7, 2.